Okay everyone, welcome back to SAT Math. This time is week 3, part 1. I have a little bit of a sore throat, so if I sound a little bit different, I apologize. Getting into it, we are doing linear inequalities. Just the basic intro. We have absolute value function. When you have an absolute value like this, where we have, a two-part component with 2 absolute value of 4 minus x and 3 absolute value of 4 minus x, you can actually just add those together and make it into 5, 4 minus x. I'm trying to make the lines a little bit thicker for the absolute value, just so it's a little bit more obvious. And then, again, you just solve absolute value like normal, and you have to keep in mind both possibilities. And they do say choose the positive solution only, but just in case, we should solve for both. The left one, 4 minus x equals positive 5, x equals negative 1, 4 minus x equals negative 5, x equals 9. That is our correct answer. Okay, for this question, we have x squared minus 2x minus 9 equals 0. One solution of this equation is written as 1 plus square root of k, where k is a constant. What is the value of k? We have 8, 10, 20, and 40. So one way we can solve this equation is completing the square. We can do that by adding b over 2 squared on both sides. And we know that b equals negative 2. And we can just plug that in as negative 2 over 2 squared equals 1. X squared minus 2x plus 1 equals 10. And then we just solve for x. We do know that x squared minus 2x plus 1 equals, we did completing the square for a reason. That makes it x minus 1 squared equals 10. Then we just solve for x, and that will leave us with x equals 1 plus or minus root 10. And it says one solution can be rewritten as 1 plus root k, which in this case just means k equals 10. Okay, for this equation here, we have 1 over x squared plus 10x plus 25 equals 4. If x is a solution to the given equation, what is the possible value of x plus 5? Okay, so we just factor out the bottom. We have x plus 5 squared. And again, we just solve for x plus 5. So, we'll just flip those and then just solve it out for x plus 5. We have plus or minus 1/2. But out of the option choices, we have positive 1/2 as our answer. Okay, this question can be a little bit more tricky, but this is kind of the ones where you have to realize, you have to cut out the fluff. So that just means you have to read this question and figure out what's actually important and what isn't. So this question gives a lot of context. During a 5-second time interval, the average acceleration in meters per second squared of an object with an initial velocity of 12 meters per second is defined by a equals vf minus 12 over 5, where vf is the final velocity of the object in meters per second. If the equation is rewritten in the form of vf equals xa plus y, where x and y are constants, what is the value of x? So this question looks really complicated, but we have this formula for a, and we have to figure out that formula for xa plus y in the form of vf, meaning we just have to manipulate this and solve for vf instead of a. We can do that by multiplying 5 by both sides, adding 12, and we'll find that we have the same formatting as what we are looking for. In this case, it's as simple as just plugging in that 5 for x, and that's our answer here. Okay, value of c. A line with equation 2y equals c with some constant c intersects the parabola at exactly one point. If the parabola has equation y equals negative 2x squared plus 9x, what is the value of c? So Even though you do have access to Desmos, you still want to solve this one out mathematically. Obviously, it helps to, visualize the graph, so if that helps you out, please go ahead and do so. But we don't know what C is, which makes this question a lot harder to do, Desmos only. So we need the vertex formula, which is x equals negative b over 2a. X equals, just by plugging it in. Oh, I forgot the second parentheses there. But we have negative 9 over 2 times negative 2, and that will be 9 over 4. We'll plug that value of x back into the parabola. And once you simplify, you'll end up with y equals 81 over 8. And that's how we know how to find c. Because we have our line y equals c over 2 passing through our vertex, meaning to find that value of y, we just find that c over 2 equals 81 over 8, with c being 81 over 4. Okay, for the greatest possible value of b, we have to use our discriminant here because we just don't have access to a lot of information, and this question says it has no real solution. And when a discriminant is negative, we know that there are no real solutions. And that real solution part does matter because, imaginary numbers and whatnot. I don't think SAT dabbles too much with, what's it called? Imaginary numbers, so it should be fine. And they will, differentiate. So just keep an eye out for, real solutions because they usually will say that. But anyway, this is our original equation. Negative x plus bx minus 676 equals 0. We know our conditions for a, b, and c. B will just equal b. And when solving for a discriminant, we'll plug everything in, and we'll end up with b squared minus 2,704 is less than 0. Remember, we have to make it less than 0 because there are no real solutions here. So when we solve for b and we square root, you do have to do plus minus b, but in this case, because we're looking for the greatest possible value of b, we only need to look for the positive value, and it also tells us b is a positive integer, so we only need to check for the positive condition. Now, we're looking for the greatest possible value of b, meaning which number matches this inequality. B is less than 52. In that case, it will be 51. And you might be confused, like, why is it not 51.99999? We want the greatest possible integer. So in that case, it will not be a decimal, which is why it's just 51. Okay, value of k. For this question, we have a system with these two, and one is y plus k equals x plus 26. The other one is y minus k equals x squared minus 5x. This system has exactly one distinct real solution. What is the value of k? So we just want to make both equations equal y. So we'll just, move k on the other side. And then that way we can make them equal to each other. Again, we just want to, again, use our discriminant here because we have one distinct real solution, meaning we can make that equal to 0. So in this case, we'll just simplify everything and make it equal to 0. And our C condition will be 2k minus 26. So when we plug that into our discriminant, same formula we used before. And this time, because we only have one real distinct solution, that we can equal it to 0. And again, just simplifying it out. I'm not going to go over the math, but if you want to, please look at it. Solving for k will be 140 over 8, which simplifies to 35 over 2. Okay, solving for w in terms of x and y, we have this long equation here, 14x over 7y equals 2 times square root of w plus 19. and we want to solve for w. So we just trying to factor out as many, constants as we can for a question like this. So the best way we can do that is just by separating this 2 from the 14x and 7y, and we'll just cancel those 2's out and have x over y equals root w plus 19. And again, we're solving for w here, so this time we'll get rid of that square root by by squaring both sides. And solving for w, we'll just move that 19 by subtracting, and this is our correct answer. Okay, how many distinct real solutions does this equation have? I'm sure you can guess by now, but again, this is discriminant, and we can tell based on if it's negative, positive, or equaling 0. This time, it will just be negative, and that just means we have 0 real solutions. Okay, x in terms of c, this is our last question. This one's pretty difficult. So please keep that in mind. We have x squared over root x squared minus c squared equals c squared over root x squared minus c squared plus 39. C is a constant, positive constant, and we're just trying to, solve for x in terms of c. Which one will it look like? So again, we just want to move all our variables on one side for this question. So we'll subtract that c squared over root x squared minus c squared, meaning we're just isolating the 39. And again, we have the same denominator here, so we can actually just simplify the equation by doing x squared minus c squared on the numerator. And this is where it gets a little tricky for some people. Keep in mind exponent rules. So we have the same thing, x squared minus c squared on the numerator and denominator. The only difference is the denominator has the square root. And when you do that exponent rule, you can just subtract when you divide, meaning just dividing this out means you have that 1 on the exponent for the numerator minus the denominator for the exponent. So just to clarify, we have x squared minus c squared on both numerator and denominator. The only difference is the denominator has a square root, and using exponent rules, when you have the same same base with different exponents, when you divide, you just subtract, and this time it will be 1 minus 1/2, meaning the fully solved out version of this will just be x squared minus c squared and the square root of that. So then when we have that, again, we just equal this back to 39. And again, we're solving for x. So we'll just solve for x, just, moving it over. And then square rooting everything. Again, we have to do plus minus, but if you look on the multiple choice, the correct answer will be the negative version of this. Okay, so that is the lecture for today. If you guys like this video, please like and subscribe.